Hey everyone! Today we're going to tackle one of the most fundamental but often misunderstood skills in software: how to write functions that are clean, easy to maintain, and just feel right. We're going to go way beyond the simple rules and get to the very heart of what makes code truly elegant.
Okay, let's be real. Every single one of us has asked this question. You've probably heard all the standard answers, right? Oh, no more than 20 lines, or it should fit on your screen. But what if I told you that's the completely wrong way to even think about the problem?
Yep, that's right. If you're measuring how good a function is by its line count, you're falling into a trap. The true measure of a right-sized function has absolutely nothing to do with its length. It's all about its purpose, its clarity, and the job it's trying to do. It's about concepts, not character counts.
So here's our game plan. First, we'll talk about why the old way of measuring is so wrong. Then we'll introduce the one policy principle. This is the core idea. We'll give you a great mental model to make it stick, hand you a practical toolkit, and then we'll walk through a real example to see it all in action.
All right, first things first, let's dig into the actual problem we're trying to solve here. When you focus only on the number of lines, you accidentally create code that's a mess to read, a nightmare to test, and terrifying to change, and it leads to a particularly nasty beast of an anti-pattern.
The God method. We've all seen one. Maybe we've even written one. It's that one function that does everything. It validates the input, talks to the database, runs the business logic, formats the output, sends an email, all because, well, that's the sequence of events. It's a monster, and it's impossible to work with.
So if counting lines is out, what's in? Let's get to the single most important rule for designing great functions. This one idea is going to be our guide for everything else.
Before we get to the rule itself, we need to define a key term: policy. When we say policy, we're talking about a coherent group of decisions. Think of it like a family of rules that belong together. So the logic for calculating sales tax, that's a policy. All the steps for validating a password, that's another policy.
And this brings us to the big reveal. This is the crucial point. A function should embody one and only one policy. That's it. It's so simple, but it's incredibly powerful. It changes our thinking from a function does one thing to a function owns one set of decisions.
So how do you know if your function is breaking this rule? Well, there are some pretty clear red flags. If you find yourself needing the word "and" to name it, like validate user and save to database, that's a sign. If it's mixing business rules with database code, or if you can imagine two different people asking for changes to two different parts of it, it's definitely time to split it up.
But wait, you can also take this too far. You can chop things up so small they become meaningless. You've probably gone too far if your function is just a shallow wrapper that immediately calls another function. If I have to read the function's code just to figure out what it's doing, it's not actually helping. A good function has to provide real value by hiding complexity.
Okay, this one policy idea is awesome, but it can feel a little abstract. So let's use a really simple and effective mental model to make all of this super concrete and easy to remember. I want you to imagine that your application is a professional kitchen. You've got a head chef who's in charge, reading the recipe and telling everyone what to do. And then you have all your line cooks, specialists who know how to do one thing really, really well. One grills, one makes sauces, one does the plating. Your code should work the exact same way. And this kitchen analogy perfectly illustrates the two types of functions we should be writing. The chef is what we call an orchestrator. Its code reads just like a recipe, a simple list of high-level steps. It doesn't do the work itself, it just calls other methods. The cooks are our workers. Each one is a specialist. It implements one specific policy, like validating the input or calculating a total. They're focused and they do their one job perfectly.
So now that we have the theory and this great mental model, let's get practical. How do you actually start applying this to your code today? Let's build out your toolkit. Here is a repeatable process, an algorithm for refactoring. First, just write down the story of what needs to happen in plain English. Then, go through and circle the different decision clusters. Validation, calculation, saving the data. Each of those is a perfect candidate for a worker function. Then you just assign the roles, one chef and a bunch of cooks.
And to make it even easier, here's a little checklist for you. Find a function in your codebase and just ask these questions. If you answer yes to any of them, it's probably a God method in disguise, and it's a great candidate to be split into a chef and some cooks.
And of course, here's the checklist for the other direction, for when you've gone a little too far with the chopping block.
If a function isn't really hiding any complexity and just adds another file you have to click through to understand what's going on, it's probably better to just merge it back into whatever is calling it.
You know, if you want to get even more objective about it, you can use a simple scorecard like this one. Just rate a function from 0 to 2 on these 5 qualities. Is its policy cohesive? Is its contract clear? If it scores an 8 or more, you're in great shape. But if it's below a 5, well, it's probably time for a serious refactor.
All right, we've got the theory, we've got the kitchen model, and we've got the tools. Let's wrap this all up and see how this actually works in practice with a super common, real-world example.
Here's our task. This is a classic, and you can just see how this is a trap waiting to happen, right? It would be so easy to just dump all of this logic into one giant function, but we know better now. So, using our model, the first thing we design is the chef, our orchestrator. Look at how this process order function reads. It's just a simple, high-level recipe. It doesn't have any of the messy details. It just delegates each step in the correct order. This is clean. This is incredibly easy to understand.
And where are all the messy details? They're handled by our specialist cooks, the worker functions. Each one owns a single crystal-clear responsibility. Validate order request owns all the rules about what makes a request valid. Calculate order totals owns the entire pricing policy. They're small, they're focused, and they are so much easier to test by themselves.
So, let's boil it all down. What are the key things to remember? First, think of every method you write as a contract. Second, give each method just one policy to own. Third, split them up when they have multiple reasons to change, but merge them back together when they stop adding value. And finally, push all your side effects, like writing to a database, to the very edges of your system.
And that's a wrap. I'll leave you with a final thought, a little challenge. Think about the code you work on every single day. I guarantee there's a God method lurking in there somewhere. So my question for you is, what's one you could refactor this week using this chef and cook model? Thanks for tuning in.